Bismillahirrahmanirrahim. Welcome to the new lecture. So it is a continuity of our lecture number 8. So here we will study about electric field due to a various charge distribution. Once we have a lot of charges and how we can distribute it, and how will be the electric field due to various charges. So okay, once we have a one charge, so it means it will be electric field, and two charge electric field, 3, 4 field, 4, so on. So when you are distributing the number of charges, so we will have electric fields, number of electric fields. So the electric field is a vector which obeys the superposition principle, as I mentioned during a previous slide. So the electric field of a charge distribution is the sum of the electric field produced by individual charges or by a differential element of a charge. Let this be a charge 1, so it will be have electric field E1. This is charge 2, this will be have electric field E2, this is E3, 4, 5, 6 and so on. So at the end what we can do, we can say that the sum of all the charges, sum of E1, E2, E3, E4, E5, E6 and so on. And at the end we can be write like that, summation, in a summation form. And we can say I start from 1 to, let's see, we have a 5 charges, so I start from 1 to 5, it will be I. So we will be right in this form. So once we have a number of charges, it means we will have a number of electric field, and we at the end, in the conclusion, at the result, we will add all the electric field which is produced by the number of charges. So now coming to the electric fields from continuous distribution of charge. So up to now we studied about a point charge. So now we are talking about continuous distributions of charges. So up to now we have only considered the electric field of a point charges. So now let's look at continuous distribution of a charges, line, surface, volume and so on. So let's say we have a sphere. So you can see a sphere like a ball. So in a ball you have a number of charges. So all the charges will be in a continuous form, in a continuous way of distribution. Once we have a ring, so in a ring, so charges will be distributed continuously in a ring shape. Okay, so in a sheet, so the charges will be continuous in this sheet, and the electric field will be generated due to this charges. So this is the electric field lines, which is generated by charges. This is the electric field line which is generated by charges from a ring. This is the electric field line which is generated from a charges from a sphere. Okay, so this is basically the distribution of a charge in a continuous form in a shape of sphere, ring and sheet. So electric field produced by a continuous distribution of a charge. Let's see. So one thing which you need to be keep in mind, we always take a discrete point charges, and we can use a superposition theorem. Okay, and what we can do in superposition theorem, in superposition theorem, we just add or sum all the field due to a point charge. Let's see, we have a charge q1, q2 and q3. Okay, so this q1, q2 and q3 is generating a electric field, and also due to electric field we have a electric force as well. Okay, so this is charge q4, and this charge q4 experience electric field or electric force due to q1, q2 and q3. Okay, so and at the end, at this point, let's see, E2, electric field due to charge q2, electric field due to charge q3, electric field due to charge q1. So what we can do in this superposition, we just add all these electric field, and at the result, so in this will be have electric field direction, this will have the electric field direction, and this will have electric field direction, and q4 is have its own electric field. So electric field experienced by a q4 charges. So apply the discrete point charges, apply the superposition principle, and what we can do, and then just sum all the field lines. So electric field from a continuous distribution charge. So what we can do, again the same thing, take a discrete point charges, use the superposition theorem. What we can do superposition, we just add all the fields. So add all the fields, so we have E1, E2, E3. So your electric field in a charge Q4, which is the summation of all the electric field. So we can say I start from 1 to, so 1 2 3, I start from 1 to 3. So it will be like, put I is equal to 1, so it will be electric field 1, then I plus, because it's a summation sign, so it plus, then it will be E2, then plus it will be E3. So this is your number of electric field. Okay, so what if we now have a continuous charge distribution? So this is your space, so make your charge in a continuous distribution form, and it will be your electric field. So now coming to the electric potential energy. So in electric potential energy, so first we need to compare the gravitational force and electrical force, Coulomb law. So there is some similarities between a gravitational force and electrical force. If you can see the formula of gravitational force, we have a constant and we have a two masses and we have a distance between them. Then in a electric force, same, we have again the force. This is gravitational force and this will be a electrical force. So we have a constant, we have a two charges, because electrical, so we are using a two charges and we have a distance. So first thing, the similarities between a gravitational and electrical formula. So this similarity also leads to a similarity between the potential energies associated with each other as well. So when these two forces have some similarities, so because on the base of the similarity we can say that we have some similarity in energy as well. So in a gravitational energy and electrical energy, so the formula of gravitational energy we already know about it, because we studied in a physics in class 10, 11 and 12. So the formula for the gravitational energy, which is equal to minus g m1 m2 divided by r square. M1 m2 is the masses of object. So due to this formula, we can say that the energy of electrical is equal to on the point of G we will use K constant, on the point of M1 M2 we will use two charges Q1 Q2 and R. So due to similarities in the gravitational and electrical force, we can conclude from a formula that the electrical energy can be in this form. Okay, because both are attractive forces and repulsive can be, both have the same concept, how the object is moving from point A to point B, or how the object is moving from one field to another field, what will be the effect. So hope you guys already have a concept behind the gravitational force, so the same concept is applying on the electrical force as well. Okay, so UE, just simply UE depend on magnitude of a sign of a pair of a charges. So UE is a positive, negative, and Q1 and Q2 have the same or opposite sign. Remember, potential energy is a scalar quantity. So energy is also a scalar quantity. So F is the energy, as is the potential energy. So energy is always a scalar quantity. So coming to the electric potential. So electric potential, what is electric potential? Is just about like energy. So once we are doing a work, so due to work we can utilize some energy. So work needed or energy acquired when a positive charge is moved from infinity to a certain point in an electric field. What does it mean? Let's see, you have a charge at a point of infinity and there is some kind of electric field. Okay, this electric field, and so you want to move this charge from infinity to a certain point, to this point. So when the charge is coming from a infinity to a certain point, so this is called electric potential. So what does it mean? When a charge is coming towards the electric field, to a certain electric field, so this electric field have some force. This electric field have some force. When a charge is coming here, so it means this charge experience a electric force. So once the charge experience a electric force, so we can say that this is called electric potential. So the simplest definition of electric potential is electric potential V is equal to electric potential energy per unit charge. Electric potential energy per unit charge. This is the simplest definition of electric potential. So when a positive charge is coming from infinity to a certain field, and that field will exert a kind of a force on a charge. When a force is exerted, it means there is a utilization of energy. When energy is going to be utilized, so it means this can be effect of electric potential. Electricity from a positive or negative charge, and potential the ability. So once you have a potential, so you can work, you can do games, etc. So once a charge have a potential, so the charge will be come from any of a field to the another field. It can be enter in a field. So scalar quantity with a unit of volt, 1 joule and 1 coulomb. So I've told you before, potential, electric potential is a scalar quantity. Sometimes call it potential or a voltage. Electric potential is characteristic of the field only, independent of a test charge placed in that field. Potential energy is a characteristic of a charge field system due to an interaction between the field and a charge placed in the field. So when a positive or a negative charge is placed in an electric field, it moves from a point of a high or a low potential to a point of a lower. So what does it mean? Let's see. We have a high and we have a low value. When a charge move from point A to point B, so this is your high point and this is your low point. So charge is coming from point A to point B, mean from high to low. Or we can say that a charge is moved from point B to point A, or we can say from low to high. Okay, so this is just like a higher potential and lower potential when moving. So as we studied electric potential, now we need to study about potential difference, because when we have a potential difference, let's see, I can say that we have a V1 and V2, and the difference between V1 and V2 is 0. So when the difference between the voltage is 0, so it means there will be no flow of current. But when there is a difference between V1 and V2, and it can give you some value 1, 2, 3, 4, 5, 6 and so on. So in such case we can say that there is a potential difference. When there is a potential difference, it means the current can be flow. So the first thing, what is potential difference? So simply you have a high value and you have a low value. So always like you have a tank of water, okay, and this is on the top of the house, and this tank have a hole in the bottom. So from a high value and from on the tank, the water can be come up from a top to bottom. So we can say that this is the high voltage and this is the low voltage. Okay, so we can say the potential difference, the difference between the high voltage and low voltage is called potential difference. So we can see this is called V2, this is called V1. So V2 minus V1 is called potential difference. This is the simplest definition. So the change in the potential energy of a charge as it moves between a 2 points within electric field, this is called potential difference. So this is the simplest definition, that the difference between the two voltage values is called potential difference. So the difference in this electric potential is what is known as voltage. So the current does not flow unless there is a potential difference present. 1 volt is, so this is your formula, volt, 1 volt is equal to 1 joule and 1 coulomb, because of potential formula, electric potential formula. So we can say that 1 volt is when a battery cell provide a 1 joule of electric potential energy to each coulomb of a charge as it moves through the cell. So it's called 1 volt. Because why he's saying, let's see, we have a positive and negative charge. This is a cell, positive and negative charge. When we have a potential difference here, because this have an electric field, this have electric field, a charge is going to be enter from this field to this field, so there will be a potential difference, there will be electric field. So this potential difference is 1 volt when 1 joule and 1 coulomb is exist inside a cell. So this was about electric potential and the potential difference. So now coming to the electric potential between a 2 point. So when a potential when a point charge q move between a 2 point A to B, let's say this is your A, this is your B, so it moves through a potential difference, or delta V will be Vf minus Vi, or we can say Vb minus Vi, simple definition of potential difference as I told you before. So the potential difference is the change in the electric potential energy as well, as we know about this formula before we studied. So change in energy divided by charge. So when there is a change in the potential difference, so it means there is a change in the potential energy. So when change in energy is there, so potential difference will be there. So the electric force of any charge plus or minus is always potential is always directed towards the region of a lower electric potential energy, just like a gravity. When we have a gravity, so up to the lower point will have a gravity, the upper point have a gravity. If you want to be make a difference between a gravity, there will be a gravity difference as well. Because it's based off energy. Every game is based off energy. So for a positive or negative charge, lower potential energy means lower or high potential. Okay. So this is the formula which we can be used. So potential difference is equal to kq divided by r. So this have also a proof how we can prove it out, but just keep in mind this formula which is helpful in for your numerical. So how we can get this formula? So it because when a charge is moving from point A to point B and enter in an electric field, so it will do some work done, and you know about it, that work is equal to the energy. So we can put the value of work in the energy in this formula, then q and q will be cancel each other at the end, then at the end we will get this formula. So it have a long proof. So just have a concept how we can get this formula. Just we have a two field, and or we can say we have a 2 point A to point B, and a charge move from point A to point B against the electric field. When it's enter the electric field, it means it will do some work done. When it do some work done, so it means that work done will equal to the energy, and just put the value of energy in this formula. And we have a q as well. So due to a Coulomb law, we have a two charges, so one charge will be cancelled to another charge, and we can get this formula. So this is the concept behind the formula. So the potential and a charge conductor. So the same is just about a formula or comparison. So we know that the energy is equal to work done. So why we are using minus W? Because when the charge is entering from point A to point B against the electric field, when it's going to be against, it means the angle will be 180, and cos 180 is equal to minus 1. That's why we are using negative work done. Okay, so it can be in this formula can also be used when there's a potential difference. So it means energy is going to be changed. This formula is get from the potential difference. So combining these two equations, so we can say that the work done is equal to minus q del V. Del V is potential difference, and we can also be used as minus q is equal to VB minus VA potential difference. Just like a formula, just put the value of del U in here and just replace minus from this side to this side. So no work is required to move a charge between 2 points at the same electrical potential. So for a charge conductor in equilibrium, so in equilibrium what we can do? So no work is done by electric field if a charge is moved from point A to point B. So in equilibrium, it means there will be no work done. So when there is no work, it means VB minus V is equal to 0, because if there is no work done, it means there is no potential difference. When there is no potential difference, it means the charge is in the equilibrium form. So it means VB once it's equal to 0, it means VB is equal to VA. So it means there is no potential difference. And there is no potential difference, there is a equilibrium. So since electric field inside a conductor is 0, So no work is required to move a charge inside a conductor because the electric field inside conductor is zero. Okay. So, and this was the concept behind the electric potential difference, and the charge inside a conductor. How we can say that the charge inside a conductor is zero, or we can say how we can say that electric field inside a conductor is zero when the potential is same. When the potential difference is same, so it's such case you can say the charge inside a conductor is zero. So let's come to the numerical. We have a numerical like example. If a battery cell provides 3.0 joule of electrical potential energy, so how is the energy 3.0? Potential energy in a moving 2 coulomb of a charge. 2 coulomb of a charge. So what is the charge? 2 coulomb. What is the potential difference of a cell? So you have this formula. You have a this is energy, not electric field. Okay, this is U, energy. You have energy, you have a charge, so this is your potential. And example number, in the second example, it takes 6 joule of a work to move 2 coulomb of a charge between a 2 point in an electric field. So energy is available, point charge is available. What is the potential energy difference between these 2 points? So again you have a this value. So work and energy is same as I told you. So 6, 2, and you will get the potential. So this is simple numerical. So try to find out another numerical from a Google, from a book, and try to solve it out. Make a practice. So make it habit in your daily life. So this was all about your electrostatic, electric potential, charges, electric field line, electric field intensity, and so on. So you guys can find it well. So watch it out. If you have any question, just raise in the comments and I will try to answer it too. So thank you for your time. See you in the next lecture.